Hello everyone, and thank you for clicking on the Literacy Volunteers of Harrison County YouTube channel. We're a nonprofit United Way agency. We would love for you to subscribe to this channel. Just click on the subscribe below, and if you click on the bell icon, it will notify you when we put up new videos. And if you like it, please give us a thumbs up and share it with your friends. Today we're going to look at properties of water. It's a little bit longer than our other videos, but there are a lot of properties of water. So 70% of Earth is ocean water, and about 65% of your body is made up of water. So why is water so important? What about water makes it an important aspect of our life? We're going to look at the unusual and unique properties of water. I don't know if you'll find them unusual or not, but they are unique. The first one is polarity, right? You've heard of a pole or polar. We have a North Pole and a South Pole right on the globe. So here we're having charge in two different areas. Water is H2O, right? So we have two hydrogen molecules and one oxygen. And what happens here is oxygen is carrying more of the negative electrons this way, and hydrogen, since only one electron, one proton, right? One neutron, 1, 1, 1, is pulling the hydrogen this way. So we have a pole. We have a negative side and a positive side to water. And that makes it a unique molecule simply because the fact that it's polar gives it the ability to do different things, right? Here we have each of our hydrogen atoms, and they are covalently bonded to oxygen. There are two types of bonds, covalent bonds and ionic bonds. In covalent bonds, we're going to share our electrons. So we're kind of sharing them with oxygen, which is why the negative charge is pulling that way, because our proton is pulling this way, right? These two positive charge. So oxygen has these two unshared pairs of electrons, and it's electronegative because it's not completed its outer energy level. And if you're interested in that, we could do a video on orbitals and, valence electrons, if you like. Water is polar. It has an uneven distribution of electron density, partial negative charge near oxygen and partial positive charge near hydrogen. This results in the formation of what are called hydrogen bonds. And hydrogen bonds are very, very important when we're dealing with the body especially. Your DNA, which we've done a video on before, the base pairs are held together with hydrogen bonds. There is a lot of energy stored in hydrogen bonds, which we're going to look at in a minute. What are the unique properties that are due specifically to the hydrogen bonds? When you put ice in water, it floats, right? It floats because the hydrogen bonds that hold the water molecules hold them further apart, right? So we've got a bunch of water molecules hooked together, but those hydrogen bonds are holding them apart. So the solid, they're farther apart in that solid than they are in a liquid, and that causes the ice to float. We have what's called a hydrophobic effect. Hydro means water. You've heard of a hydroelectric plant. Phobic means fear of, right? So our hydrophobic effect is the exclusion of compounds that contain carbon or hydrogen or non-polar compounds. So we have they repel each other, right? Polar compounds and non-polar compounds. If you had a glass of water here and you poured vegetable oil on top of it, and it kind of starts to go and then it pushes it all to the top, that's because oils and fats are non-polar molecules, and the polarity of water pushes them apart. This is very important in your cell membranes in your body. This is called, the cell membranes called the phospholipid or the lipid, which means fat, bilayer. So we have two sets of fatty acids that are joined by these little heads. And these heads are called hydrophilic because they love the water, so they face the water. Their tails face the middle, and they're called hydrophobic. They fear the water, so they're pushed away from it. That's where we get the polarity differences between nonpolar and polar and how they interact. Those fats, lipids, oils, those are the nonpolar ones, and the water is going to repel those due to the strong hydrogen bonds that hold the water molecules together. Have you ever heard the expression oil and water don't mix? That's where it came from. Boiling point and freezing point. Water has a small molecular weight, which means that when we add up the oxygen and the hydrogen, we don't get a large number, but it's an incredibly large boiling point. The boiling point of water is 100 degrees Celsius, right? And so this occurs because the water requires more energy to break those hydrogen bonds before it can boil. We've got water sitting here, we heat it, right? The water molecules start to move And as they move around, they gain energy. But we can't get it to boil until we start to break it apart. And that's when it starts to, you see it bubble, so you know it's boiling, right? It takes a lot of energy to break hydrogen bonds. The same thing occurs when we freeze water. The two factors that we just looked at are important to organisms and water ecosystems. Freezing point and boiling point. We want to have a high boiling point of water right in this low freezing point, because you have those organisms that live in the water, and those drastic changes could disturb their environment. That could cause them to die. So we need to have this large amount, right, of degree of separation so that those organisms can live. Density is another factor. It's the ratio of mass to volume. And I kind of wrote out the equation here for you. This P means density. I don't know why it's a P. And it's mass over volume, right? We're dividing mass by volume. That's the ratio of those two things. Mass, right? We looked at mass, how much space something takes up. And then volume we'll look at that as a function of mass. Dense objects feel heavier, right? And they tend to sink, while less dense objects feel lighter and they tend to float. So if something's very heavy, very dense, we put it in water and it sinks to the bottom, right? Or if it's not, it'll float. The density of most objects change as temperature changes, because we have all the molecules packed close together, and as they warm up, they get kinetic energy. They start to move, right? So warmer temperatures make substances less dense due to the random kinetic energy, the movement of the molecules. They're moving apart. They don't want to be together anymore because it's warm. If they're cold, they're all huddled together. As we warm them up, they separate, right? The density of water is a very special case, and I've drawn some little pictures here for you. In the summer, and then the fall before turnover, and we'll look at what turnover is, and the fall after. So the water is most dense at 39 degrees Fahrenheit. As it cools or warms from that set point, it expands slightly, right? So this means that the ice is slightly less dense than cold water. So what happens? That's why it floats on the surface of bodies of water. So when the lake freezes in the winter, why is the ice not on the bottom? It's less dense, so it floats to the top. Right? The floating ice slows the freezing process. So it's kind of insulating that water underneath of it, so that that layer of ice is keeping that water that's below it from freezing all the way through, right? So the layer of ice, it prevents many lakes from freezing solid. That way the fish and the other organisms can survive. If all the water underneath froze, then the fish would survive, or the fish wouldn't survive. Turnover occurs when the water on the surface of the lake cools in the fall, and then it will eventually become more dense than the water beneath, so the cold water will sink to the bottom and the warm water will rise in this instance. So that's the turnover of the lakes. This just helps keep organisms be able to survive. Another factor is surface tension. Besides mercury, water has the highest surface tension of all liquids. You probably don't remember, but if you're older and watching this video, they used to put mercury in thermometers, right? It would tell us you'd put it on the bottom in the little bulb, and then the mercury would rise or go up and down. They don't do that anymore because mercury is carcinogenic. They use alcohol. Usually ethyl alcohol. Surface tension is the property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of its molecules. Again, the cohesive nature comes from the hydrogen bonds that hold the water together. So we've got those hydrogen bonds that are between the water molecules, and they're constantly pulling the molecules in many different directions, right? All over the place, because it's moving, it's not static. So you've got that water, that bond, those hydrogen bonds. And then the surface of the molecules, those ones that are at the top, are only going to be pulled right side to side and down. They're not pulled up, there's nothing on top of them. You're at the very top of the water, we can only pull down or side to side. We can't pull up, there's nothing here to pull up, right? So now we get
or we might be in Cuyahoga Valley National Park.